Listen very carefully. You will get MCQs also, so pay attention. Yeah. Sickle cell solubility test. So before that, what is sickle cell anemia? Tell me, students. Very good. The shape of the RBC is in sickle shape. Keep in mind, sickle shape happens, genetically speaking, this is an autosomal recessive disorder. Okay, autosomal recessive disorder. That means you need two problematic genes to get a disease. You need to get two genes with a diseased genes, then only you will get the disease. Okay, you need two affected chromosomes to get disease. If you are carrying it, one chromosome is normal, another chromosome has a mutation, then you will become a carrier. Okay, the sickle cell carrier is also called as sickle cell trait. Sickle cell trait. The carrier of sickle cell and condition is also called as sickle cell trait. Okay. Now listen. Disease we already know. In case of diseased individuals, when we perform the peripheral blood smear, when we took the tongue smear, obviously we will see sickle shape RBCs. Sickle shape RBC will be seen in sickle cell disease. Okay. Whereas in the sickle trait, their RBC looks normal. Their RBC will be in biconcave shape. In sickle cell trait, the RBC will be in biconcave shape. But during deoxygenated conditions, during deoxygenated or hypoxic condition, the cell will transform to sickle shape. That means when you perform PBS to a trait individuals, to a carrier individual, you won't see the sickle cells. You will see normal cells. That is how these patients are asymptomatic and they will be misdiagnosed. They will be escaped from, we won't catch them easily because of this phenomenon. Got my point? Now, what are the threats to these people? The threats is when these people will have a healthy lifestyle. They will have a healthy lifestyle. But when they are doing some oxygen demanding tasks like diving, okay, maybe I can say oxygen depleting tasks. Diving, when he is diving into the water, he needs to hold his breath. When he is holding the breath, obviously the oxygen levels will decrease. So chances of converting his cells to sickle, he will get some issue in the body. Second one, when he is hiking, as our Kushi said, when he is climbing any mountain or if he is going to Kullu or Manali, if they have this sickle, they will get some complications after reaching Manali. Because in Manali there will be oxygen levels will be comparatively less compared to in Chandigarh. So they will get some problems. Now I will tell what problems they will get. That is called a sickle cell crisis. In sickle cell crisis, you just imagine there are small blood vessels in the eyes. Okay, there are small blood vessels in the eyes, and imagine the sickle cells blocking these blood vessels, leading to blindness to the patient. Blindness can happen, ocular sickling. Okay, ocular sickling can happen. Second one, respiratory shock can happen. Respiratory shock. What is this respiratory shock? Sickle shape, the RBC will block in the alveoli of the lungs, so they can't breathe properly. There will be some internal bleeding. Okay, this is a respiratory shock can happen. Third one, I forgot the term here. Splenic puncture. Splenic puncture can happen. That means spleen will be ruptured. Inside the spleen, the sickle cell RBCs will rupture the spleen, leading to heavy hemorrhage, heavy bleeding, and they might die. This is splenic puncture can happen. Okay, splenic puncture can happen, and other interesting things are there. Positive things there in sickle cell also. Remember, malaria parasite can only destroy a biconcave shape RBC. Malaria parasite can only enter into a biconcave RBC, but it cannot enter into a sickle cell RBC. Okay. Now, what evolution favored in the areas where there is more malaria? It favored them to have sickle cell anemia. If I want to protect, okay, there is a malaria pandemic now. If any one of you have sickle cell anemia, you will be survived and others will die because of malaria. Okay, only the sickle cell individuals will survive. Then you given birth to your children, the children who has a sickle cell, they will alive and others will die. Gradually, after 100 to 200 years, this room will be filled with sickle cell students rather than normal students, because that is what the environmental pressure, natural selection happened here. This is what happened in Africa, where tropical regions, where there is a prevalence of more malaria. So obviously sickle cell anemia is more prevalent in Africa, or the areas where there is malaria. Okay, so most of the Africans are sickle cell traits. Okay, so that is the thing. So now you understood the etiology of this disease, right? Yeah. Then last and final, how to perform this test? How to perform sickle test? Very simple. I will take the blood sample in a tube. I took the blood sample. Then to this blood sample, I will add saponine. This saponine will destroy the RBCs. Okay, I need to tell one more thing. 1 second, students. I need to tell one more basics here. There are 3 types of or 4 types of hemoglobins. Tell me. Hemoglobin A, adult hemoglobin, hemoglobin sickle, hemoglobin fetal, hemoglobin HbA1c. Okay, that is for the glycemic status. Okay. Any more you want to say? No, enough. Okay, 4. Now listen. Hemoglobin A, F and HbA1c won't precipitate in alkaline solution, whereas sickle cell hemoglobin will precipitate. It will form crystals in an alkaline solution. Only sickle cell hemoglobin will precipitate in the alkaline solution. When I say precipitate, it will become insoluble in water, in alkaline water. Okay, this is one property of sickle cell. Okay, that is why I will tell how we are doing this test now. Listen, first I took our blood sample. I added saponine. Saponine will destroy the red blood cells. It will lyse the red blood cells. Red blood cells are lysed. After lysing, to this I will add an alkaline solution, that is phosphate buffer solution, plus phosphate buffer solution, alkaline medium, plus I will add, I need to remove oxygen from this patient. If I remove oxygen, the sickling effect can be seen. Am I correct? That is what sickle cell anemia, right? Oxygen, removal of oxygen will turn HB to sickle shape. Do you remember? Right. So here I will add a reducing chemical, redox reaction. That redox chemical is dithionite. 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 Dithionite is the reducing chemical, redox. Reductase. Anyway, it will remove oxygen from the sample. Now what we are expecting, what happens? Now the hemoglobin will be precipitated as an insoluble complex. Insoluble complex. Now, insoluble complex will have turbidity in the water. Do you agree with me? What is turbidity means? Tell me. Compared to water, you see some aloe vera gel. Aloe vera gel is a turbid in nature compared to water. Okay? So, I will give you one example. There is a ruled paper and I kept a normal water test tube and I kept aloe vera gel. In what tube you will see the lines, in water you can see the lines, whereas in aloe vera gel, the background lines won't be visible. Got my point? Similarly, in sickle test, the blood already becomes turbid. So what happens in sickle cell anemia? The lines will be disappear. Disappearance of lines indicates positive to the sickle test. Appearance of lines indicates negative to the sickle test. Why lines are disappeared? Because the blood becomes turbid. Why it becomes turbid? Because HbS is present in the sample. Whereas HbA, it will dissolve in the blood. So we can see the lines. This is how we will perform the test. So there are ready-made kit is available. You need not to add these reagents. The direct step is like this. 20 microliters of blood sample plus 20 microliters of reagent. Okay. Wait for 5 minutes. Then observe in front of a ruled paper. That's it. If you see the lines, positive to sickle test. No lines, negative to the sickle test. A simple rule paper, not record any scientific rule paper, nothing. That rule paper is sufficient. This book is sufficient. Okay. Yes, Kate.
So if you ask for the procedure in the exam, you write that one on the side.
You will write whatever I given in the record. Simple. In this record, okay? As per the material I took here, this is the procedure, okay? From kit to kit it will differ. Okay, and also don't confuse with reagents. Those reagents will present in a single mixed reagent. Usually in the outside we need not to memorize the reagent names. You just need to understand the concept, that's it. How we are doing the test. What is the logic behind, concept behind the test. That's it.
One question more.
Yes.
So this is dialectic 9, this one redox reagent.
Yes, redox reagent.
So it is specified phosphate buffer or additional?
Phosphate buffer and this dithionite both will be same. It's a single suspension.
So we have to add that phosphate buffer to those.
Yeah, that's it. Under blood, I added reagent. Reagent has everything. That's it. It has everything. Okay. Any more doubts?
Can you write the reaction?
Huh?
Can you write the reaction?
I don't know. I mean, I need to go with biochemistry reaction you are asking.
No, so that.
Yes. At biochemistry level, I can't. I need to go with profiling rings. I'm not that much expert in chemistry. I will tell you. Listen. Red blood cells plus I added saponine. So saponine. Okay. Saponine. What it did? It lysed the RBCs. It lysed the RBCs and released the HbS. Now released HbS is subjected to phosphate buffer plus dithionite. Dithionite. Okay. Now this dithionite, what it did in the presence of 5 minutes, it made an insoluble precipitates. Insoluble precipitates has been happened. These insoluble precipitates are turbid in nature. They are turbid in nature. This turbidity will be detected by placing the tube behind a ruled line. If it is turbid, we will get lines will be disappeared. That will be positive test. If lines are still visible, then this is negative test for sickle cell. That's it. Now listen. This test is called a sickle cell solubility test. That means we are soluble. What is that?
Means
Synonym for soluble. The cells have been dissolved. Very good. Dissolved. Cells have been dissolved. Thank you. Okay. Sometimes no. Okay. Now listen. This is not a standard gold standard test. This is the simplest, cheap and effective test. As we will go with the cheap test first. Effective test. The ideal approach will be detection of sickle cell trait by PCR. Genetic testing should be done, clinical history should be assessed, and also we need to assess any other acquired conditions. Is patient has any toxins? Is he intoxicated with any drugs? Because some drugs will induce sickle cell trait. We don't know. We need to cross-verify other differential tests also. But this is the common test we are doing for sickle cell anemia. Any doubts so far? Yes.
Sir, if anyhow hemoglobin is not sufficient or not in its proper state,
Yeah.
can it be effect to this test?
Huh?
Sir, if anyhow hemoglobin is not working or not in a proper shape, like alpha chain is absent or beta chain is absent, is there any?
Very good, thank you. Yes, Shubham. Listen, class. I forgot to tell one more point here. I'm sorry. I forgot this one. HB has
Two chains.
hemoglobin has two types of chains. What are those? Alpha chains and beta. 2 alpha, 2 beta. Actually, sickle cell affect the beta chain of the hemoglobin. Sickle cell disease happen because of issues with the beta chain, not with the alpha chain. Beta chain defects. And personally, I also remember regarding sickle cell anemia, this is also called as point mutation. Point mutation. You know what is point mutation means? Only single nucleoside base pair. Okay, I forgot it is A is replaced by U.
Glutamic acid replaced by
U. Wait. A adenine is replaced by uracil. This lead to replacement of glutamine amino acid into valine, and this valine is responsible for sickle cell. I will let you know in a simplest way. In the Shembulingam textbook, it's a very big textbook, right? Only one word was misprinted. Only one letter. Okay, one word. Okay, one alphabet in Shembulingam textbook. Maybe in page number 700, second paragraph. The PCV was wrote as a PVF, and you got a sickle cell anemia. Just as one alphabet difference in our body. Out of 4 billion letters. Out of 4 billion letters, one alphabet misplaced, and you got a disease. See, they are the point mutations. We are very lucky that all our 4 billion alphabets are correct. See how lucky we are? And this is happening every day. Very interesting. Okay, anyway, this is all about sickle cell anemia. You should be thankful to yourself. Yeah, yes. Okay, that's it.